everyone. Welcome to this session called Data-Driven Design, AI, Immersion and Visualization in Fashion. My name is Stephen Westland and I work as a Professor of Colour Science at the University of Leeds. And I work as part of the Future Fashion Factory, which is a creative cluster funded by the government and led by industry. And today we have 5 speakers. 4 of those are technology partners of our Future Fashion Factory, and 1 of them is undertaking university-based research. So what we're going to do, we're going to have 5 presentations of approximately 10 minutes each. And at the end of that, we might have a little bit of time left for questions. I'll be checking in the chat to see if there are any questions, which we'll wrap up at the end of the session. So without further ado, I'd like to invite Adam Boyne from Beta Jester to come to the stage and give his presentation.
Thank you, Stephen. Hello. Just going to bring that up now. Perfect. I'm going to assume everything is fine, and if there are any issues, someone can tell me. But otherwise, all good. So, hello, everyone. My name is Adam, as personally introduced by Stephen. I run a company called Beta Jester. Beta Jester are a technology partner of Future Fashion Factory, and today I'm going to be talking about immersive training, specifically looking at immersive technology in the use of training and development. And I'm going to relate it in general. I'm going to talk generally about training and the state of training that we have in the world, particularly look at some of the benefits of things like virtual reality, augmented reality, and then begin to relate it to where it could change things in the fashion industry specifically. So without further ado, there's going to be about 6 sort of different points. There's going to be no time for Q&A at the minute. The Q&A will be coming at the end of all of our sessions. So any questions, please do post them in the chats, and then we'll get back to you at the end. I will also leave my email address. So if you have any specific questions for me, you'll be able to drop me a message. So without further ado, let's talk about the state of training. So training has obviously been around for a very long time. Anyone who's ever taken on any kind of job or role will have been involved in training in some kind. As you can see here, we've got an example of people being trained using loom-based technology and that kind of thing. And as technology has developed, so has training. Now, the problem that you get with training is that, generally speaking, it comes with a very high cost. Now, this cost could be related to the fact that you've got to take individual experienced people out for the day, so they can't be working on creating product or that kind of thing. There might be issues around courses. So for example, if we take the oil and gas industry, a typical 3-day course for them would cost around £2,000, which means that every time you've got to train someone, that's £2,000 you're going to have to spend on them. But this isn't just for like in oil and gas and sort of high consequence industries. It's also, if you're just training HR people, it's still going to be £870. These are expensive forms of training people, and their costs that come back every year, every time you hire a new employee. They're also dangerous. I'm sure everyone's heard stories of people in these industries who have suffered injuries because they're learning. They have to learn on the job, and sometimes you have to work with dangerous equipment. There's a high potential for risk, untrained staff in these hazardous environments. And also the worst part about the danger part is that it's difficult for people who train to retain the information they are given. We've seen through studies that only 10% of knowledge is retained after a year from traditional training, which is why we get into the area of refresher courses and this kind of thing. So the reason that VR and immersive technology can change this is that they have the power to sort of bring us into new spaces, allow us to do things outside of our sort of day-to-day. So just a quick intro to virtual reality if you're still wondering what exactly it is. So VR is fully immersive. You can't see anything in the outside world. Interactable, you're able to go and touch things, move things, handle things, and it's reactive. It's able to react to you doing stuff. So it's able to, if you open a door, the door opens. Augmented reality, in contrast, is about bringing real digital content into the world. So it's about, being able to see a sofa in your living room, as opposed to seeing it in a fantasy world or in a virtual warehouse, etc., etc. It's interactable. Again, you can touch things, move things, drag things around in that space, and it's collaborative. It gives the opportunity for different people to see what's going on in that space. So that was just a quick intro. Any questions on AR, VR, come back to me. Where AR and VR training comes into it is that they're both able to take what is existing training and convert it into a digital space. So this isn't like you having to start again from scratch. You've already got something that works, a form of training that you think is powerful, that you think teaches people well. You're able to just recreate it immediately inside VR. So no need to rewrite brand new courses. it's improved accessibility. More people are able to access it, right? Because it's a virtual, it's digital. You don't have to go and buy bespoke training equipment. You don't have to go and take one of your machines offline for the day. You can quite easily recreate it in a virtual scenario and teach people on it. And not only can you then teach people on it, there are benefits from it being purely digital. The fact that people can do it over and over and over again. The fact that if somebody is consistently failing on a particular aspect, so where they're causing the machine to break or something like that, you can get reports on that and you can find that out. You don't have to wait until that person breaks an actual machine and go through the rigmarole of paying for repairs or paying to fix it or paying for the cost of changing it. You are able to take that on immediately and find out that information. So essentially what we're looking at with VR and AR training and immersive training in general is the ability to take what is an already existing training platform and convert it into something that makes it easier for people to do. A good example of this in the real world is a company called Lloyd's Register. So Lloyd's Register are a UK-based company who they deliver training to people who have expensive bespoke equipment. They're not quite in the fashion industry, but they are in industry similar. So it's lots of expensive equipment, lots of heavy-duty equipment. They took on the idea of rebuilding their training inside virtual reality, as you can see here in this video. So this is an example of a virtual scenario, but with real equipment. These are all examples of things that have been remade digitally, cranes and trains and engines and pipes and pumps and all this kind of thing. It cost them an amount of money to build it. So for them, it cost £40,000 to build this. But because they were able to then go out and get a 3 times return on investment because it saved them so much money in other spaces. It saved them on danger, it saved them on insurance, it saved them on retraining, it saved them on paying for new courses, it saved them on updating. Everywhere else they saved money, they were actually able to make money off the back of building this. So even though sometimes it can seem that there's a high upfront cost of this kind of thing, actually what happens in response is you're getting better training, more efficient training, adapting that can change over time. It's cheaper, it's easier to run, and just across the board, better training. So just to give you a quick insight into other businesses, in case you're wondering, but isn't this all brand new? And do I really want to be at the forefront? This exists in industry now, right? Walmart, for example, they train all their employees on dealing face to face with customers, right? And they saw that there was a 10 to 15% improvement, even for people just watching somebody else in VR, because the novelty factor adds to that. Adweek, who are a marketing company, they found that 53% of people more likely to purchase from companies that use VR. 71% thought companies who use VR more forward thinking. Verizon found that when they used it for customer training, there were just improvements across the board. And Johnson & Johnson, a surgical company, found that there were 233% higher scores just across the board. So you're probably now thinking, well, I've got training in place. Do I really want to switch to this? It seems like a high cost. It seems like this. Not only all the reasons that I've already outlined about why VR is better, but when you compare it directly to traditional training, there are some immediate comparisons. Number one, increased retention. You may have noticed about the fact that when people go through traditional training, we're talking your multiple choice questions, your PowerPoint presentations, you're watching a video and answering questions that sometimes you can go back to them 2 weeks later and they're not sure what they were meant to remember. We've actually found studies have demonstrated that in VR training, people retain the information 80% higher than after a week than compared to only 20% in traditional training. That means even after a week, people know what to do. So if there are intricacies, if there are dangers, if there are things like you absolutely have to remember to lock this or unlock that or push this safety button, wherever it is, you've got a 4 times higher chance of knowing that if they've gone through VR training. And on top of that, there is a reduced injury risk. People are more aware of the things that could cause injury. We've seen a 43% of reduction in injuries in high consequence environments. Now, traditionally, yes, of course, that's your oils and your gases and your explosives and your chemicals. But we all know that in the fashion industry, there are dangers. There are things that that could hurt people. There are needles. There are machines. There are things that are moving very quickly. And once you've got an injury, that's somebody taken out for a long period of time, which is just a situation you just don't want to be in. And a 43% reduction is a huge amount to is not an amount that you can just shirk off. And finally, long-term memory. I know this is something that is very important to the heart of a lot of these places. We found that 70% higher rate of memory retention over the long term. Over a year, people are still remembering at a higher rate than those who go through traditional training. And if you want to look beyond that, just at future-proofing your industry and your company, straight up the bat, ubiquity, right? This is not something new. This is something that 39% of large companies are now integrating into their system. They are bringing in VR and AR training because it's important that they were able to make the most of these technological advances. Knowledge retention, right? This is a hugely important factor. The fact that there are so many experts in the fashion industry who have years of experience. If they were to retire or to move company, you have the possibility of losing that knowledge. Through VR and AR training, you are able to rebuild your scenarios around your experienced employees, build their knowledge into a digital scenario so that you are able to teach people from that knowledge over and over again for years to come, and lose the risk of losing out on that knowledge. And finally, training from home. We're in a weird scenario now. Remote working is important, and it's important to know. And VR and digital training is the only way that you're going to be able to bring those heavy-duty equipment into your employees' homes to train with, allow them to mess with parts and to figure it out in their own space. Now, finally, I just want to talk quickly about how it can be improved for your business, right? If you wanted to take up this opportunity and sort of start thinking about how you can use VR and AR training, convert your existing training. Take what you have already. You don't need to start from scratch or rethink it. Just work with somebody who can take what you've got already, convert it into VR and AR. Explore the new opportunities. See where you can take it from there. Do you want to make it more dynamic? Do you want to add in new equipment that you haven't had access to? And then finally, push beyond where you currently are with your training. You are able with these methods to do something spectacular. Why don't you use the opportunity to turn it into something crazy and make the most of these new methods of training? So I have been Adam. This has been the talk on sort of introducing you to immersive training, specifically for the fashion sector and beyond. If you do have any questions, please do feel free to email me at inquiries@bejas.co.uk. And thank you for listening.
Adam, thanks very much. That's a fantastic start, and it's generated quite a few questions. I'm really interested in your comment about greater memory retention.
Absolutely.
We'll deal with these questions at the end of the session, like we mentioned. So what I'd like to do now is introduce the second speaker, who is Daniel Norbery from Vertalis.
Hello, good afternoon. I hope you can all hear me okay. I'll just try and share my screen.
We can hear.
Perfect. So I just want to say thank you to Adam for that really good introduction and a great overview of what VR really means for industry. So I'm going to slightly expand on that as well, just to get a bit of context into some of the statistics which Adam talked about. So I'd like to just talk to you about what I think it means to be innovative. Imagine you could go to work in the morning anywhere in the world and be able to see and understand everything that your teams are doing, everything that different departments are doing, everything that the entire supply chain is doing, and understand what impacts you. This is a definition of giving meaning to data, in other words, context. So many of you may have seen these three themes before. It's a standard themes which drive activity. So if you look at the communication challenges associated with these themes, if you look at people, for example, it's very obvious to think about the communication challenges for people from different countries and different languages. But then people from different backgrounds and then different skill sets, depending on their education, also talking different languages. There's various different communication challenges associated with processes, such as understanding what is happening in your supply chain, the mitigation of duplication of effort, and being compliant with standards and regulations, more specifically export control, so you have a fully aligned global organization. Then we look at the technology tools that are currently in play to deliver information across organizations. We use spreadsheets, PowerPoints, which you're all witnessing right now, 2D drawings, and product lifecycle management software. Imagine there was a single connected tool which gives context of information for all of these technology endpoints. Now, I'm going to go on a slight tangent here, and I'm going to share with you, talk about the novel Alice in Wonderland. And I'm going to share with you how I think Alice demonstrates what it means to be innovative. Bear with me. So if we start off at the beginning, where Alice sees something strange in the world, she sees a white rabbit running by her. Now, many would see this white rabbit as being very unique just in the UK generally. But this white rabbit was talking about how it was late for a very important date. It had a watch. Now, many would see this as being strange, and we wouldn't even think twice about chasing it because we don't know what the risk would be. We don't know where it would take us. However, Alice's curiosity won her over, and she decided to follow this rabbit, this strange thing in her life, to see where it took her. It took her into a place called Wonderland, where she met a range of different characters. Now, these characters challenged the way she thought. They challenged the way she thought about how she made her come face to face with her communication challenge, with communication. She couldn't manage her scale effectively. So therefore, Alice found creative solutions for these problems, and had the ability to grow as a person. This allowed us to move forward along the path and find the right direction. Now, many would think that chasing this white rabbit has put Alice in a situation where she was being challenged unnecessarily. But if you look at it from a different perspective, she was able to grow because all these individuals, these characters, challenged her in this way, and she was open to finding creative solutions for them. So putting this into context, she saw something strange in her life, saw this white rabbit which she chased. This can be reflected in seeing new innovation, new technology on the horizon. New technology which potentially is a risk to an organization or to a person because it's not been used before, or maybe it's not been used in this industry before. Alice found a platform to experiment. She found the community who were willing to challenge her, and she was open to these challenges and found creative solutions for them, which enabled her to grow. This can be reflected here today at the Beyond conference, where we have a range of different communities available to us. And if we're open-minded enough, we can look at these communities as people, as organizations who are willing to challenge the way we think. And then from this, we can think of ways to develop further and move forward in a more progressive way. This is what it means to be innovative. Now, Alice then found a place to then experiment with these new skills because she came face to face with a real challenge in the form of a Queen of Hearts. This can be reflective of us taking advantage of the communities around us, learning from them, and then going back to our organizations to tackle real problems that matter to us. So how is this reflective? How is this reflective to XR technology, for example? I'd like to just share with you. So I come from a company called Visualisation, and I want to challenge the way you think about virtual reality, augmented reality, otherwise known as XR. Now, as Adam rightly said, this is a very effective tool for training. But if we think about why this tool is effective for training, it's because it's a communication tool. It delivers information, it gives context to information so it can be digested better and more efficiently. Now, if we think about it as a communication tool, our horizon's open. We think about how can we bring this communication tool into our meetings, in our daily meetings. How can we use this communication tool to understand everything that's happening in our world without having to move anywhere? Now, there's a demand for this sort of capability, and currently the demand is the performance demand on hardware. It's unrealistic, or it's thought to be unrealistic, to have huge visualizations which take in all the data from an entire organization all in one place, which people can tap into. And then we think about the restrictions associated with the hardware requirements. Do we need to have servers upon servers to ensure we can crunch these numbers? Vitalis has been around for the last 25 years, and we've developed visualization technology, visualization software, which focuses in on this problem. We've developed a solution where you can have an entire visualization, such as some things that Adam was talking about just a moment ago. You can have the entire factory shop floor, for example, all in one visualization, and you can look at it on your mobile phone. You can have bidirectional information streaming to and from your phone, or to and from the scene, should I say, which you can tap into. You can use mobile devices such as tablets or laptops. You can use VR headsets, AR headsets. Everybody can see the same scene. Everybody can use the same scene, and everybody can collaborate in the same scene from anywhere in the world. This is what Vitalis does. We think about the bigger picture. Now, this is add-on from what Adam was talking about. This is the other side of the spectrum. This is giving context to data. So there's a whole range of complexities when it comes to this technology. So it's down to us to ask the correct questions to see what it is we can do and why we should do it. So I hope this has been inspiring for you. I'd like you to reach out to find out more about our company, because I've only got 10 minutes, so I've not been able to give too much detail about what it is that we really do, in regards to our software. So please reach out to us and have a chat so we can talk to you more, and we can have a look at some of the communication challenges which may be associated with your organizations. So my details in the top right-hand corner there. Video here is one of our customers. They use our technology as a communication tool. This is one of the VR scenes that they've built using our tool. As you can see, the scale of the operations are huge. And the value they've got from this is because they have very risky activities associated with their job. They have to go out into the ocean and build assemblies on the ocean bed, which costs pounds each time. So what they've done, they've mapped out the entire process, got the entire offshore oil rig all in one environment, so they can of the whole operation. Straight away, we see getting return on investment for activities and saving hundreds of thousands of pounds. I hope this has been inspiring for you, and please reach out to me. Thank you very much.
Thank you very much, Daniel, and also fantastic time management. Well done. By the way, feel free to put a link in the chat to your company so people can just click on it and get more information.
Good idea. Thank you.
I just did that also for Future Fashion Factory. But on that, I'd like to now invite Mike King to give his presentation. Mike King is from Numerian Software.
Thank you, Stephen. And following on from Adam and Daniel, I want to talk about some of the sort of technology that they may use in their VR tools. So basically, we're all familiar with the challenges facing the fashion industry, including the race to get online, the need to reduce returns for financial environmental impact, and the challenge of engaging customers digitally, etc. And clearly, one of the keys for addressing these challenges is being able to believably represent those physical fashion products that we deal with in a digital world. Now, actually, there is another industry that's already doing this and that we can look to for guidance. And while you certainly know about that industry, maybe its relevance to virtual fashion may have escaped you. So the movie industry is already using virtual garments, truly believable, seamlessly, without the audience realizing, and that's just the point. And here at Numerian, our background for the last 10 years has been providing the garment simulation tools to that movie industry. And our carbon software has been used for garment and flesh simulation in many blockbusters over recent years. However, unlike in the movies, fashion is not looking to spend $100 million on a production. And so they don't have the budget for the sort of character effects teams that movies have, where they might end up handcrafting many scenes. So here at Numerian, we've been looking at how can we bring our tools that give a high quality, believable garment simulation and make them cost effectively available to other industries, such as the fashion industry. And so for the last 18 months, we've been working with the support of Innovate on developing the Carbon Digital Fashion Engine. And this digital fashion engine is a combination of a workflow and a live simulation and rendering engine. So if I can just grab the cursor here. So basically, fashion artists are already familiar with their tools for developing 3D garments and patterns, such as Marvelous and Optitex and similar. What we are going to allow is them to take the output from these tools, and by adding a little bit of carbon magic, which might take 30 minutes for a relatively simple garment, maybe a bit longer for something more complex, bring those into the VR, AR world. Now, you might ask, why don't I just bake out the animation frames from the design tools. Most of them can do that. But the problem is they are just baked out frames. So you can play an animation that you've already created, but you can't do anything interactive with that. You can't use it in any sort of interactive way. It's sort of like baking it to a movie and then you're stuck with what you've got. So there are many, many other ways that these assets can be used. And here are some of the scenarios that Carbon can support. So you may want to combine multiple garments on demand to create outfits, to mix and match, potentially from different suppliers. You may want to do virtual try-on. You may want to simulate against a soft skin rather than the hard skin that the design packages use for swimsuits and lingerie, or even face masks, for example. You may want to animate the characters live, driving them with mocap, or interacting with other objects in the scene. Or you might just want other things associated with the garments, such as a gold chain around the neck of a person, or similar types of items like a handbag pushing against the clothing. And Carbon can support all of these scenarios offline today. So at this point, I would love to show you this live, but we're still a few weeks away from being able to do that. So instead, let me walk you through a few scenarios captured from our testbed environment. So the first one is the ability to drape multiple layers fast and accurately. And here to simulate and render each of these garments is about 1 second for each layer. And we can render them extremely accurately. So, if any of you have used the 3D garment design packages, you'll know that one of the things they're very poor at is handling multi-layer. And obviously, if you're trying to do it live and you're trying to do it believably, it's just got to work. And that's one of Carbon's real strengths, is amazing collision quality. And so from our test bed and from what will be in the live system, we're basically delivering back to a web page 6 images to show 6 views, and also a couple of close-up images as well. Now we're rendering these thanks to modern graphics hardware with incredible detail. So here in these scenes with 3 garments, we're rendering 6 million triangles in this scene. And that's essentially instantaneous from a rendering perspective. Now, 6-7 years ago, when we explored some of this before, rendering was actually the bottleneck, not the simulation. And so it's very exciting that we can now render very fast as well as simulate. Because at the end of the day, it's the visual picture that is appealing. The simulation is just a means to an end. The other thing we can do is virtual try-on. And so you've got 3 different bodies here. We can do that either with predefined bodies, or we're entering live information on body size. And we're going to kick off a virtual trial with Flare Fashion in the new year. And then finally, time's obviously quite short, so I'm just going to skip through a couple of other things that we can do that aren't in the test bed at the moment, but are in our tool set. So one is interacting between rigid objects and the cloth. So here, for example, we've got a chain, and the chain's pushing against the cloth, and the watch is pushing against the cloth, and the cloth is pushing back. And here we've got a more complex scenario where we're actually tying a shoelace. And Carbon can do all of these very effectively. And then just finally, if I can persuade this to move on to the next slide. There we go. No, one more. Come on. A very topical project we've been working on is face mask simulation. Again, with a soft skin, because simulating a face mask against a hard skin surface is of relatively little use, because we've all got more or less soft skin. So that's what we're about. And as I say, that type of technology is going to appear in our own products, but also in the products that Adam and Daniel talked about. And I know there were a few questions about how can I get the experience of the feel and the weight of fabric? Well, it's using Carbon that you can get that experience of the movement of the cloth, the feel of the cloth in the virtual environment. And with that, I'll hand you back to Stephen. Thank you very much, everybody.
Thank you very much, Michael. Great presentation. And there is a question, but I'll pick it up at the end of the session. On that, I want to introduce our penultimate speaker, which is Paul Jarvis from 12 Oaks Software. Hi, Paul.
Yeah, how you doing? Okay, good. Yes, excellent. Right, hello. My name is Paul. I'm director of a company called 12 Oaks Software, a bespoke software agency based in Central York. So I'm currently involved in a research project with the RCA and University of Leeds around enabling digital thinking within fashion. Our project has been graciously funded by Future Fashion Factory, and it is a proof of market to find out information around the user needs of systems intended to shorten supply chains and support fundamentally the reshoring of UK manufacturing via digital systems. So the way that we're approaching that is through understanding what is needed for businesses to be able to think digitally and work out the skill sets that are required for those businesses, as well as the product development process that's currently in place within those businesses. Little thing stopped working. There we go. We also have a section around the user needs for 3D weave technologies. And a lot of this is around the tooling available and the bottlenecks therein. So we want to be able to find more information about the systems that are both in use and required to support the innovation of designer, manufacturer, and consumer relationships. Being able to do things like take a system that provides auto grading of the patterns to be able to then trigger an event for a 3D weave, say a specific person's fitted garment to be 3D weaved and produced, and then be able to be sent out to that customer without the need of creating, let's say, tens to hundreds of thousands of a certain sized garment that isn't going to fit everyone. It's actually going to fit very few people, but comes close enough to as many people as possible. You'd then be able to focus on more honed garments, more tailored, if you will. Because of this, what we're looking to do is engage with designers and industry to be able to get your goals and systems and bottlenecks to be able to inform us about what is required to be done. But our main thrust begins in January, and we're going to be getting in contact with whoever we can to be able to research via interviews and questionnaires how industry actually uses these systems. So that would be the design tools, how the design tool outputs a file, and perhaps how the to then create digital patterns from those digital designs, what needs to happen to be able to convert from the output of this file into the input of this system. And then following on through to the next step in the process, which may be, say, sending that file over to a manufacturer who then requires it in entirely own file format. So we're trying to find out how the process works for the industry in general to be able to allow this research to make something that is less ethereal and more beneficial for as many people as you can. We'd greatly appreciate anyone's involvement. If it's something that interests you, feel free to contact me on email research@12os.co.uk. Alternatively, if you're in the need of bespoke software solutions for your businesses or require independent third-party software auditing, you can contact me directly at Jarvis at 12os. It's on the other side. Yeah, that's us. That's my thing. It's very short. I'm done.
Thank you very much, Paul. And I appreciate you being slightly short, actually, because we started slightly late, so you've really helped me out there. And we're back on track now. So thank you very much for that. So in fact, the Future Fashion Factory is an ecosystem of more than 250 different companies, and you've heard from 4 of our technology partners today. But we also do academic research too, and Paul's presentation reminded me that although Future Fashion Factory is led by the University of Leeds, it also includes academics at University of Huddersfield and Royal College of Art, which is where Paul is working. And in our last presentation today, we're going to hear from one of our researchers working at the University of Leeds. So if you'd like to come forward, Peiwa, and give your presentation. This is Peiwa Lai, actually I'm not sure, Lai from the University of Leeds. Yeah, sorry. I should know because Peiwa is actually my PhD student. Okay, off you go, Peiwa.
Okay. Yeah, I hope everyone can see my screen.
We can.
Yeah, cool. So let's get started. And I'm Pei Hua, a researcher at the University of Leeds. And my project is about data-driven color forecasting. And the aim of my project is trying to create some data-driven tools that make an impact in the global fashion industry. And I'm currently working within the context of Future Fashion Factory, which is a creative cluster funded by the UK government. And one of the strengths of the work is AI and machine learning. And the work I'm going to present today is in this area. And as we might notice that the fashion show is a very important platform to deliver the color trends insights to the company and customers in current situations. Instead of sending the fashion expert to attend the fashion weeks in person, some companies still choose to recruit fashion experts to analyze thousands of catwalk images from the show each fashion weeks and to determine the color palette and find out the retail opportunities. And especially in the COVID situation, some fashion weeks decided to be held online. So we should not ignore the importance of the fashion runway images in the process of color forecasting. And part of my project is trying to automatically extract colors from the show that can represent the clothes. And this task can be used as part of the color forecasting procedure. We might all notice that there are existing softwares that help us to extract colors from the images. For example, the Adobe Color. I put an example here. The color palettes generated by these apps are not perfectly fulfill our need because the color they extract, including the color of the floor and the color of the background. So we need more sophisticated approach just to extract the color to represent the outfit for us. And one technique we involve into my research is called objective detections. And it's a deep learning technique that helps us with solving these problems. And it can automatically grab the person for us to extract the colors. And we involve this technique into our data-driven systems. And here are some sample outcomes from the data-driven system we proposed. We use the Burberry ready-to-wear collection as an example, and we could see on the right, the color palettes generated by our data-driven system combined all the outfits from that single shows. And we will deliver this kind of information to the company that can help them to make correct decision in a quicker way and a cost-effective way. And also, if we deliver this kind of information to the customers or users, it might help them to get a trends insight in a short time just after the show. And in order to test the performance of the model, we conduct a consumer experiment. And we asked the participant to select 3 colors to represent the outfit from the fashion shows. And then we can see in the middle, there's some color palette here. And each row just represent the color selected by each individuals. In the consumer data here, we use as the ground truth data to test the performance of the machine learning models we proposed. And on the right side, we could see the color palette generated by our assistant. It's not that hard to visually compare the similarity between the ground truth data and the color palette generated by our data-driven system. But of course, the visual comparison is not enough. So we did a quantitative comparison between the color palette and the ground truth data, but we do not have enough time to explain more details on it. So if you are interested in it, you can just read the journal that we published this year to know more quantitative data and the technical details. And however, the data-driven system we propose is not perfect. We still work on the procedure to remove the skin color involvement when we generate our color palette here. Okay, so now maybe some people might ask, the data-driven system is always performs than humans. And my answer is no, because the data-driven system we proposed here is not trying to replacing human. In fact, the human can do better color extraction on a particular image compared to the data-driven systems. Indeed, the use of the consumer data as the ground truth data is a tacit admission of that. So why are we still trying to build a data-driven system to automatically extract color palette for us? The reason is that we are living in a data revolution world. The data-driven system can always work better when a task that involves too many image data for human to deal with. We can see the news here. In the past, during each fashion week, there are more than thousands of images float online. So it's not that possible for human to do it manually, to read every image and extract colors for us. So we propose this kind of data-driven system to help us to solve these kind of problems. Also, the contribution of our data-driven system can be expanded into the task whenever there are too many images for human to deal with. For example, the Instagram. We all know that there are 95 million of images and videos are uploaded on the Instagram per day. In the current color forecasting procedure, we cannot ignore the rise of social influencers and customer involvement on it. So the data-driven system we propose can make a huge impact on the fashion industry in order to get the color trends and color insight in a quicker way and in a cost-effective way. And there are 2 highlights for my today's presentation. The first one is that the data-driven system we propose here is trying to generate a new workflow which help humans to do the work that cannot be manually finished. And the other one is that the data-driven system we propose here is trying to improve the work efficiency for color palettes generation. Because we are living in the data revolution world, there are too many image data that we are going to solve and going to analyze. And one more project that is doing within our research group is called the Colorpedia project. The idea is that the color has meanings, and the designer often seek color palette that could represent a word or concept. So the system is trying to automatically generate a color palette in any word in English or any language in the world. And the system is built by millions of image data obtained from the internet. So if you got this project might interest some of you, and if you guys would like to know more about it, you can just explore it within the links. Okay, so thanks for listening. That's all for me today. Okay.
Peiwa, thank you very much. And by the way, Peiwa's in China today, so thanks for staying up so late, Peiwa, to give this presentation. And also, it was a great test of the technology because it worked perfectly without any lag. So we do have time for some questions. I've got a list of questions. There's quite a lot. So my first question actually is for Adam. It was from Caroline White, and she was asking, how will AR in the future interface with AI? What's the relationship between AR and AI going forward?
So AI has a lot of applications in these kind of spaces, particularly the fact that it's sort of been alluded to in a couple of other talks. We're able to start pulling out information from people and learn more. I mean, how we use AI to sort of figure out where you are in the world when we're looking at an augmented reality experience, where we can start to take from that and then give things back to you. So if you're in a park, give you more experiences built around, you know, show you trees and plant life. Whereas if you're in a building, maybe we show you more chairs and things, and being able to direct your experiences. AI has a lot of applications across the board, so it's going to be exciting to see how it develops. But I think immediately it's going to be more around delivering better experiences to individuals by using AI to figure out, you know, how do we adapt things for people who are in remote areas or have slow internet, for example.
Thanks, Adam. But a question for Michael King, was about things like the weight of fabric. You know, how can users get a feel for things like the weight of fabric in carbon?
Yeah, so I think in the virtual environment, they literally can get to feel the weight and see the movement and and actually move the cloth with their virtual hand if they've got a glove, for example, and basically haptics, which is an area we're exploring with another company called Generic Robotics, is the haptic interaction with garments and fabric, and so this is an important area for certain types of applications, and certainly one I'm sure that Adam would and Daniel would appreciate for their training as well.
Yeah, the same question was asked around Adam and Daniel's presentations too. There's a little bit of chat about that. Do either of you want to come in on that question, Adam or Daniel?
Yeah, sorry, here we are. Yeah. So the idea of sort of the hands-on stuff is interesting, that these two technologies are kind of charging towards each other. So how we can make VR feel more real. Certainly initially, obviously, we now have things like being able to do hand tracking, so you can use your own actual hands and stuff. We've got haptic gloves, which give you feedback. Getting into sort of weight and that kind of areas, it's more going to be in terms of reactive, so in terms of you can see how it responds. But we're sort of, things are moving in that direction currently, so we're trying to get to the point where we can start to weight things. And there are sort of research spaces where we've got things that do work in that space, things that limit how much you can sort of push your arms and stuff. But yeah, it's definitely an area where the real world still has the advantages, as it often will. But I think we're getting to a point where the virtual space has got a way of representing it with so many other advantages that we're gaining a lot of traction in that area.
And we're also at Leeds doing some work on how to measure with a machine things like fabric handle, and then how to replicate that or transmit that in maybe a virtual or AR space.
Yeah.
So part of the Future Fashion Factory is between this interface between academic research and then real world research and application going in companies. Daniel, do you have any comment about that? If not,
Yeah, I'm just thinking about the range of different technologies which we're talking about here, and the real purpose behind visualization and VR technology. It's designed to bring it all together at the end of the day. So there's various different user cases for each specific technology, and it's all dependent, and it's all dependent on the challenges which each organization face at the time. So it's more of a case of, rather than thinking about, you know, having a look of saying, you know, do we want to adopt visualization or VR technology because of this one user case? Thinking about how do we start with focusing in on this tool, and then breaking it down into the various different user cases, and then looking at the hardware requirements associated with it to make it even easier to move forward with.
Yeah, I think just to just add, I mean, slightly following on from Adam's comment, there are a lot of technologies out there in very specialized areas that already do some of these things which those of us that are not in those areas don't realize exist. So, you know, Generative Robotics, for example, has a dental simulator, and I tell you, that is just like going to the dentist. You can feel the pressure, you can feel the pop as it goes through the skin. You know, the technology you need to handle fabric already exists. Unfortunately, those are £10,000 machines to get that sort of. And so a bit like I was waiting for graphics to get to the point where we could render in real time realistic images. You know, we need this technology to come down in cost so that we can deploy it in more cost sensitive applications, basically.
Thank you very much. Is Paul still here? Because there's a question for Paul, which is, does he think there are any unintended consequences of using AI in fashion?
I mean, sure, AI doesn't always work. People have to write it. But there's also a difference between, that probably gets missed a lot, there's a difference between AI and machine learning. Because AI itself is just applying predefined rules, whereas machine learning is generating new rules to apply to that decision making. You can have things where, like I was saying about the auto grading systems, that might be based on machine learning to inform the AI to then process the images it can see to determine what the appropriate grade is. And it can very easily just explode is the wrong word, but you know, essentially it might see me here like this, and I might have a lot of stuff in my pockets. And it goes, oh, well, Paul has a very fat belly. Make sure that all of his clothes cover that big fat belly of his. But, you know, that's the thing that the computer can't always make that decision unless it knows the process it needs to look at. It's a thing that over time will definitely get ironed out. And it's also a thing that can be mitigated. Generally, the way you end up mitigating these things is with alerts around certain ranges. Something does something a bit too far in one way or not enough in another way. And then that can flag something up to have someone else review it. So that could just go to a human review, and then the human can have a look and go, no, that's actually not right because of whatever. And then that in turn can then be used with machine learning to feed that back into that decision-making process.
But thank you, Paul. Really helpful. Really helpful. There was one final question. We're not going to have time to ask it. I'm going to ask it, but we can't answer it. I'm going to leave it hanging. The final question was about: are there barriers to adoption that people are coming up against, and how are these being overcome? I suspect there's like a 15-20-minute discussion we can have upon that. But unfortunately, we don't have time. I think we have to finish at 1:10. So I'd just like to say thank you very much to all 5 speakers. Really interesting presentations, especially to Peiwa, because it must be nearly midnight in China now. Thanks for taking part. And I've really enjoyed being part of this session. I hope people who've been watching it have enjoyed it too. In the chat, there's all sorts of ways in which you can contact the people who presented today or follow up these issues. So please don't hesitate to do that. Thank you very much.